Okay, let us wait 1 or 2 minutes and we can start always. And let me give you a short background. We are in front of a very important day for tomorrow, the International Women's Day. And Landata is a project where we have a very important and key presence of women's leading the project. First, Cecilia as our leader. And we are very happy that today we have a panel composed by women's, all experts in the areas, in different research fields of the Atacama Desert. So it's really interesting that we can make the connection for tomorrow. And I say sorry for my voice. I hope you can understand me. I face a cold and I will give the word to other people, but I hope you can understand me. The idea today is to, as you can go to the presentation, please, Cynthia. Camila, okay. The next one. To have our seminars, Cecilia will explain very well the objective of the seminar, but it's really to create this community around this impressive Atacama Desert where we are working. Let me say that I am also part of the research team. My name is Rodrigo Palma, and I am professor at the University of Chile, which is also participating in the project. So I am very happy to be part or had the opportunity to be the moderator today of this activity. Next slide, please. This is our agenda today. We have a first presentation of Cecilia. All of us knows very well the trajectory of Cecilia, but I will give a very brief overview of that. And then we have our keynote speakers in these 10 minutes presentations regarding the relationship with research and the Atacama Desert, for each one, motivation, etc. And after that, the idea is to start a plenary session with some hopefully very flexible and comfortable conversation about first the reaction of some of the attendees to your presentations, and then also the reaction of the panelists again, if they can make some thoughts, and let us see how we can make final remarks and looks to the future. This is our agenda, and only to say, you know, Cecilia is a doctor of philosophy in microbiology from the University of Buenos Aires, and she's also directory of the Biotechnology Center at the University, Catholic University in the northern part of our country, the Universidad Católica del Norte. And you know that Cecilia research work has been mainly related to the study of microbial communities in the extreme conditions associated with the desert altiplano volcanic environment, and to industrial research in biomining processes. I know that you know very well all the contributions of Cecilia, so I will let my words until here and give the word to Cecilia to move forward in this webinar. Thank you very much.
Well, it's a pleasure to have you here, all of you, the local people, and Natalie, Teresa, and the people that we expect that join us also. Well, the activity that meet us today is in the frame of the project Landata that Rodrigo introduced you, and with this kind of activity, we look for the improve our relationship and to create social value, and to establish the links between the academy and the community and the public and the private sectors. Now we need to work with you to highlight the importance of the Atacama Desert in the different research areas, not only in the local environment, but also in the international environment of science and technology. The next, please. Well, this project is a project financed by the National Agency for Research and Development, ANID, and there are also other 4 projects that are working now with simultaneously with our project that is related with the subantarctic places, the ocean, also the mountains, and our project is, we call it Natural Laboratory of Adaptability, Resilience, and a window to look at the space, the origin, and the future. Because when we meet together to propose this project, we know that the desert means for us all these things, adaptability, resilience, and so on. Next one, please. Well, we are a group of researchers with different kind of experience in the Atacama Desert science and technology. You know most of them, and also a work of professionals that assist our team to develop this project. Again, the new one. Which is the objective of the Landata project? It is to articulate a multidisciplinary and multi-institutional academic node in the Atacama Desert Natural Laboratory to generate science, technology, knowledge, and innovation with the citizens, with the community, as a means to promote the sustainable development and highlight the natural, scientific, cultural, and so on value of the Atacama Desert in northern Chile and for the countries too. Next one, please. How we work, which was and is our methodology. Just to say that this project is 1 year project, just 1 year project, and we start last January at the very beginning of the 2022. See? So at the very beginning, in the first stage of the project, we worked together to define what was the territory that in which we will work on, and the singularities of the Atacama Desert in this territory. So it means easy, but it took us a lot of time and discussion to define the territory and the singularity. After that, we start a second stage to try to identify the case studies because we have only 1 year to work, and we need to identify some case study that provide us enough information to prepare the roadmap and what we need to define as a diagnostic for of science and technology in the Atacama Desert. After that, when we establish the territory and also the case study, we start doing the dialogue process. So we meet with people, different kind of people and representatives of different communities in each case study, also with scientific experts, local one, and now with you, and also with strategic stakeholders of the community. We establish different places to work and to dialogue with the different actors. Now we are working in the generation of the baseline and the roadmap to promote the science, technology, knowledge, and innovation in the Atacama Desert. It what will be the result of our project. It means that we will prepare a portfolio of new initiatives, project actions, monitoring programs, perhaps times, and governance. This is the methodology of our work. Some of the results they want you to see. Next one, please. Those are some pictures of the work done in the different case studies. For instance, in the Bahia de Mejillones, in Yamara, also the Loa River. Next one. This is another picture of the same kind of work. We work with them trying to understand what was the limestone in this territory, and also the significance of the different places. And also is our work with the scientific people here, local people in the regions of the northern Chile. Next one. And this one were the meeting with different kind of people from the public and the private sector from these regions. The people from the science, from the industry, and so on. It's okay. Next one. Some of the results. This is a concept map of the singularities at the Atacama Desert. It means easy, but it took us also a lot of time and discussion to create this map. At the end, we understood that in the Atacama Desert, we have some main singularities, like the subduction tectonics manifested, so it's clear to see it in the Atacama Desert, the subduction tectonics working on, the hyperaridity, the geochemical anomalies of copper, lithium, boron, molybdenum, for instance, the Anthropocene that is also very well manifested in this environment, and the life in extreme conditions. In each of them main singularities, we can find a lot of the singularities that convoke us to do the research in the Atacama Desert, for instance. The fault system in a plate conversion scenario, the high solar radiation, the exploration and mining and maintaining also, some extremophilic microorganisms, the presence of paleoclimatic records, fossils, biosignatures, and archaeological records. Well, it's just for you to understand how we try to understand the singularities and how to work on the roadmap that we have to prepare. Next one, please. We were also studying the literature to understand, to try to prepare this diagnostic of the science and technology that is being done in Atacama Desert environment. So it is, for example, in the area of astrobiology, which are the main countries that work in this area, the number of documents, and those are the documents that are elaborated and published alone by each of the countries, and the other one that is published in collaboration with other countries. So you can see that this kind of information can help us to understand how the science and technology is going on here in the Atacama Desert Natural Laboratory. Next one. So just for introduction, I think that you can, with these few words, to understand more or less which is the line of our project and our objectives. And we want now to hear you and all the people in the audience. Thank you very much.
Thank you very much, Cecilia, for this introduction. I want to make some remarks. First, to say thank you for coming and to join us, to all the people who are now in the Zoom connection. It's more than 30. And important also to say hello to our colleagues from ANIT. You know, this is our science agency in Chile, Cristian Vázquez, Fabio Zamorano, and Tomás de Aguirre Cox, that are also part of the audience. And it's very important to have the opportunity to exchange some ideas later with them too. So, but now we move to our first keynote speaker, Natalie Cabron, as you can see. And the next slide, please. We hope, Natalie, that we make a good summary and can present you as a planetary scientist and director of SETI Institute from the Carl Sagan Institute for Studies of Lifetime in the Universe. And it's really a great opportunity for us to hear you. For example, I am from the energy part of the science, so not related with these topics. And you will see in our group really a multidisciplinary approach. So it's really an opportunity to hear a different view of our Atacama Desert. And let me say some few words about your trajectory. Together with her team, Natalie is in charge of analyzing the adaptation of living beings in extreme environment and ecosystems, or with drastic changes in temperature, in addition to the study of relevant habitats of planetary exploration. For this, she has to travel around the world to the environments and more adverse and dangerous ecosystems. And we know that you know very well our Atacama Desert in your research. So very welcome, and please, the word is you.
Thank you very much. Can I ask you to let me share the screen?
Yes, of course. Camila is in charge. You can, if you can, or Emilio. So you need to stop the sharing screen, Cynthia. Camila, pardon.
Just let me know when I can.
Okay.
Yeah, thank you very much. Can you see that?
No, we are
not yet, but
now. Yes, now, yeah.
Now we can, yeah.
Okay. So thank you very much for the invitation. And as you mentioned, I am kind of a Atacama Desert rat with my career really spending now over 20 years. I think I met with Cecilia and Guillermo in 2002. And since then, it's been pretty much nonstop. I just want to go through some of the things that we've done together and maybe give you a hint towards the end of where we can go from there, or at least I would wish to go from there, from the things we've been doing. So as you mentioned, I'm a planetary scientist, I'm an astrobiologist, and I started in the Atacama from the standpoint of analogs to the Mars environment, because I was mostly involved with Mars exploration at the time and the missions with the rovers. So this is my angle when I started in the Atacama. And when you look at that, I mean, obviously you and I know better than it's just not because it looks similar that it is similar, but in that case, it is very similar. So one of them, the Gale crater on the left, is Mars. The other one is the Atacama. There was more than just morphology in the analogy that drew me to the Atacama. But also the fact that the Atacama itself gives us a range of environments, of features that are very similar to the places where we are exploring right now on Mars. But when we started 20 years ago, we still had to understand what could be the effect of the environment on the specific landforms and features, but also how could we train our technology to be effective in exploring another planet. So this is what drew me to the Atacama, first with rovers, but then on foot, because as I mentioned, it's not only that the Atacama looks a lot like Mars, it has probably the best overall environmental analogy to Mars. As you go up in the Andes, you have a thinning atmosphere. You also have the strongest UV radiation measured on the ground in this area. You have the kind of daily temperature amplitude that you would find today at the equator of Mars. Strong evaporation, low precipitation, also the fact that the Atacama is probably one of the regions hit with the Andes the most by climate change right now. So for us, also a very nice perspective on what climate change could have been on Mars 3.5 billion years ago. You see all of these environmental analogy with early Mars. So this is really why we came here, to see what could happen. The only thing that was a little different, or a lot different, is the amount of oxygen in the atmosphere. But other than that, that's pretty close. You have the hydrothermal environment, volcanic environment, desiccation, etc. So overall, over the years in Chile alone, my team and myself, and I have to say that the collaboration with Cecilia and Guillermo and their students has been a 21-year-old collaboration. In that time, we've explored not only Chile, but also Bolivia. But in Chile, lately, we've been exploring and surveying Cerro Grande, Licancabur, but on the Bolivian side, Salar de Paranales, El Tatio, Laguna Lejía, Aguascalientes, and also the summit of Aguascalientes, the volcano. What we are looking are for geological, morphological, environmental analogs, and also testing our instruments and exploration. And an important thing that took a lot more importance in the latest projects is really biosignature detection. Understand what kind of life is there, and what kind of environment it inhabits, and what kind of instrument resolution, spatial scale and spectral resolution we need to detect them. So what we run into as well were very, very powerful UV storms that we monitor over the years. We were, in 2003, we witnessed a few things that people didn't believe until other teams started to find the same thing, and the Atacama is not immune from the same storms. So the UV environment is also a great analog for other planets, and something that we keep at this time monitoring. So this is the kind of subject that I think that this group should be interested in, because the Atacama, the Andes, and the Altiplano are a very special place when it comes to the monitoring of UV environment. And we have high UV. We are at a special place just because of the Van Allen radiation belt that's re-entering the atmosphere in this general area. There are a number of reasons why UV could be high, but it also has some societal implication that, in my view, we should study in great detail, because we need some monitoring system. We need to understand those UV storm, and we need to have a kind of a monitoring system in the same way that we have for the UV index, for instance. So to me, this is something that I still have in mind that I want to develop, because people should be warned. There are people living really high in the Altiplano and also in the Atacama, and there is a lot of stuff going on with the atmosphere that needs to be monitored. Another one aspect that we did that was important for the Mars exploration is really trying to understand what kind of lacustrine environments are developing in the Altiplano. What you see here is the summit of the summit of Aguascalientes, the volcano, Simba. And Cecilia, you did the study of the exchange and environment habitability of this type of lakes. And this is typically helping us understanding what could survive, what could have developed and survive on Mars, for instance, and how to measure that. Another aspect of what we've been doing, this is for the past 7 years, the study just closed at this point in time, is when you have life developing in this extreme environment, like in the Atacama, how you detect it, because this kind of life is going to be made of extremophiles. So this is interesting anyways for the Earth aspect. What kind of life survive, what kind of abundance, but also how you detect it. So this was the goal of our NASA astrobiology project for the past 7 years. And what we did was basically understand the kind of organisms that were living there, where to find them, identify them, and also develop the techniques to detect them or their analogs on other planets. So we went to Salar Grande. Here we looked at saline environments and the type of organism that live there. And Salar Grande offered an interesting study for surface atmosphere, a lot of evaporation going on, how microbes are surviving in there, what is the geochemistry, what is the analogy for Mars again, because we are doing this project as a way to support the Mars 2020 mission. So trying to figure out analogy with what was going to be found at Jezero crater. We started the project 3 years before, and we were funded basically to support that mission. Then we went to Salar de Paronales, because there we find the type of transitional environments from carbonate to sulfates, and also high UV and different morphology, mineralogy, chemical signatures, and multispectral signature that could help us understand what we're seeing on Mars. Obviously, we looked also at stromatolites and patterns of life, and developed some what I would say are key operational methodology that connect orbital data with microhabitat, which is a huge problem, because when you are doing exploration on Mars, we have tons of orbital data, but right now Perseverance at Jezero is looking for microbe and microbial habitat, ancient ones. So how do you connect those two things? In fact, that I have been fighting forever with NASA to tell them that the orbital data is not relevant, because what happens to microbial habitat in the extreme environment is very local, but this project was able to connect those two things. So this is something we want to build on too, because it has more implication than only planetary exploration. And I will explain why a little later. Then we went to El Tatio, because that site connects hydrothermal activity, volcanic activity, high UV environment. So always the same story, but we are changing sites to have different analogy with what we're seeing on Mars. And then Lagunas Aguascalientes, these are cold spring. Remember, Mars is a lot colder than the Earth, and also lost its energy a lot faster than the Earth. So you have to think that in time, we would be switching to cooler and cooler environment, including when you have interaction with volcanic environment. So we looked at pigmented algae and bacteria, how what kind of record those are leaving in the fossil record, for instance, and how you can detect them. And then Laguna Lejía, this is more of a lacustrine environment with typically changing of condition, some of them with high waters, some of them with volcanic activity that all of a sudden buries your lake under ash and pyroclastic material, something that would be extremely relevant for Mars. And there too, we looked at different signatures of life and how to detect them. So some of Cecilia's students, and I think Cynthia, you were the one with the brush looking at those stromatolites here. So you spent quite a bit of time on that, but also to give us a really interesting idea on the succession, morphological and mineralogical in those type of environment. What you are seeing on the bottom right here is also some of the testing of our instruments, like a Raman-Leib spectrometer and what kind of signature we have in this type of environment. The idea there was to use instruments that were on board the rover on Mars so that we can create a library of biosignature and geosignature that could help and support the Martian exploration. And then, of course, there's the series of rovers and rover field experiment that we have done over the years. When you know what you are looking for and when you're developing the technologies and instruments to detect them, then you have to simulate, do real-time simulations of missions on Mars. So this is what we did. The first one that you have in Chile now, because I think that was the suitable place for it to be, is the Nomad. We started all. And with Nomad, we demonstrated mobility with rovers, but we did very little science. With Zoe, that was different. We started to use a rover to try and detect life. So we had two incarnations of the project. One was in 2000, from 2003 to 2006, and the other one was 2011 to 2015. And we made a number of demonstrations. The first one was about trying to identify life that could be at the surface, mostly using fluorescence. The second project was about how do you drill on Mars. All of these missions were real simulation with real science team, remote science team, and remote science operation. So for us, it's an incredible testing bed for future missions. And we continued with the most recent project with in situ instruments and drone. We're testing the use of drone and the use of in situ instrumentation. That's on Cesaro right now. The drone was used pretty much as an elaborated chopper, like Ingenuity is right now for Perseverance on Mars, except that our drone was a bit smarter and could do more things than Ingenuity. But again, you know, it's here, the Atacama is incredible because it gives us pretty much the right environment with the right scale, with the right organisms where we can test our mission before we send them and build incredible libraries. So what that helped us to do is to develop instruments like the Raman spectrometer or the Kemen instrument. That one is on the Curiosity rover, the other one is on the Perseverance rover, and actually another one should be on the European rover whenever this one takes off. So a lot of work being done in collaboration with UCN, mostly in Chile, but also lots of publications. I think that we have a good deal of those publications that you're showing for the US, Cecilia, over the years. The latest one was yesterday and was published in Nature Astronomy and shows this integration from orbit to the ground. And this is my last slide. And I want to conclude by saying that there are two great angles that I see today for the research to continue this type of research in the Atacama. One is how do we decrease ambiguity in biosignature detection? We have a huge problem in astrobiology is that we don't know what life is. So it's really difficult to recognize it if you see it somewhere. So we are looking for ways of improving our biosignature detection capability. And the other thing as well is that, and this is a huge priority for the Institute now, is how do we adapt the tools and strategies for planetary exploration to support the fight against climate change? And there the Atacama Desert becomes a very critical, very strategic place because of all the things I already said. The Atacama is going through a huge transformation at this point. We see the transition with the Altiplano and the Andes, but what we do for planetary and space exploration is that we are building smaller and smarter tools that are a lot more efficient, because we have very little time when we are exploring planets to understand what's going on. And basically the climate change here on Earth is facing us with the same kind of problem. We have very little time to figure it out. And being able to implement those strategies and test them in the Atacama can be a huge critical and strategic test bed for helping develop critical exploration strategies for climate change. And this is something that I'd like to try and interested this group in, because I think that this is extremely important to do. Everything else we want to do and continue, we were interested in the origin and environments the environments for the origins of life. At this point in time, I am also interested in testing new exploration strategy for the nature of life. I'm not getting into that discussion right now, but we can talk about that later. So these are the three angles: biosignature detection, bringing back the tools of planetary exploration to the Earth, and exploring the nature of life. And with that, I thank you, and I will respond to questions if you want.
Thank you very, very much, Natalie, for this impressive overview and the connection with our Atacama Desert. Thank you very much. I know that many of the attendees, they want to start with the questions, but I encourage them to write down. And I look the face of Ricardo, he's happy, no? And with this type of topics, and we want to put all the questions and the conversation in the plenary session. So now we want to move to our second keynote speaker. If you want, exactly, thank you, Cecilia, Camila. And now I want to invite Teresa Jordan to give the talk. I want to make some few remarks about your trajectory, Teresa. Teresa is a geologist and also with postgraduate studies in that field. She joined Cornell University in the late 70s, and from 2003 to 2008, she was chair of the Department of Earth and Atmospheric Science at Cornell University. In year 2005, Professor Jordan received the Lawrence Luss Award from the Sedimentary Geology Division in the Geological Society of America. So she's also fellow of the Geological Society of America and a corresponding member of the Argentine Geological Association. So many, many recognitions for the long and great trajectory. Her research focus on the climatic and hydrological history of Chile's Atacama Desert, and on finding more environmentally friendly ways to meet society's energy needs using subsoil resources. So we are very interested to hear and to know more about your experience in the Atacama Desert. Teresa, please, if you can start.
Thank you. Thank you. And I'll share I sent a presentation, but I'll share what I have. Okay. So I am a geologist trained in the temperate climates and trained to only think about rock, not about gas or life or water. But the Atacama has been, because it is completely unique on the planet, it's such it demands thought in a way that I don't think any other place demands so much thought. And I'd have to say that geologists, especially me as an example, who were prepared to think about geomorphology, to think about sedimentary processes anywhere else on the planet, are just completely unprepared for what the Atacama has. And those of us who focus greatly on the Atacama need to keep in mind that we have to promote it to the outside world, thinking of how little the outside world understands of what we're saying. So So and this is true at the large scale as well as Natalie has been telling us about at the minute scale. My first experience in the Atacama, 1983 at a geological congress in Antofagasta, but then in 98, I first went to Salar de Atacama, and Dr. Chong had told me something about how the landscape would be breathtaking, and it truly was. So I thought, I am now studying the Atacama Desert. It is a beautiful place, and happily the evaporite deposits preserve details of climate change in the last 100,000 years. But within a very short number of years after that, invited by geologists of Cernahuamin, I began looking at other parts of the desert and discovering that Salar de Atacama it's sort of like the beautiful touristic end member of the desert, and it is not at all typical of most of the hyper-arid desert. The early focus of those I was working with was on tectonic history, the tying to the Landata's node or foot in tectonics. And I was very appreciative that because erosion is very slow, therefore the cumulative impacts of solid earth interior processes uplifting the Andes Mountains from the west or uplifting the coastal Cordillera is preserved over long time scales in the landforms themselves. So we could reconstruct long-term uplift history. But by happenstance, we also stumbled across the fact that youthful gravels were held ancient tree trunks in them. And so it was sort of a wake-up call that even though things are preserved for very long times, the environment has not been completely static, and that there's much to be learned about climate history. And over the next decades, I would learn that it wasn't sort of a singular, easy thing to learn about climate history. The history of climate change in the Precordillera or highland areas was much more exaggerated than it was down in the Pampas, and yet there were consequences in the Pampas as well. But when I say that the Atacama Desert geologically is unique, I think an outside geologist can get started to unravel parts of history that they have some experience brought in from elsewhere with, like stream erosion or tectonic uplift. But the surface itself of the Pampa del Tambrogal and the Cordillera de la Costa is just inexplicable to someone who has not gotten together with their Chilean colleagues to think this through and talk this through. These surfaces just don't form in other processes, and they form so slowly. The example on the left, this surface is at least 10 million years old. The one on the right is at least 2 or 3 million years old. It doesn't happen in a place with more changeable climate than that at the low areas of the Atacama Desert. And I choose these pictures partly to show that while small, spatially small scale studies can evaluate the soil forming processes, one can put out dust traps, one can do chemical profiles and piece together the soil forming processes. It's at a landscape scale huge areas covered by these surfaces that the Atacama is at its most unusual and extreme, in my opinion. And so I encourage this Landata team to consider the question of how to encourage preservation of some large tracts of this desert. It is chemically, while I'm speaking of landscape, there's unusual chemical concentrations accumulating slowly through time that turn out to have mining value. You know, we all need lithium for our cars and various other things that are here, iodine and what have you. But we should not chew up the desert surface entirely when it is the only place on Earth that has these properties. Progressively, though, I also decided that given the anthropogenic aspects, the use of water for any number of sensible, productive values in the Atacama Desert, that there was certainly the risk of overexploitation of water. So with collaborators from various Chilean groups, including the UCN, I began working with them to understand groundwater. And as I say, I'm a geologist who only thought about rocks, not about water. Thanks to this work, I've learned to think about water as a part of the system, underground. But there's still so much to do. We can learn about the paths through which water is flowing or being stored in these, whether it's the Calama Basin or the Pampa del Tamarugal or various different places. But we still are far from really understanding fully the recharge history of the aquifers and the consequences of overexploitation. And then I hope it's not my swan song in the Atacama, but it turned out that work begun with Serna Min in 2002, in which the professors from the UCN also contributed, became like a thorn in our sides that someday had to be finished. And so the Quiagua subbasin, the area with Salar de Uyamata in it, was just a place in which numerous sub-stories converge in some complex historical manner to create the geology of the subsurface and the consequence of erosion by the lower river. And so this was the last major project that I've been involved with, involving a huge team of Chilean collaborators. And it has proven that, even though it took us 20 years to do, that it's really illuminating to try to think through how the subsurface water compositions and content in the pores have changed as the landscape as well as the climate have changed. And this diagram on the right is too complicated to follow, but it basically says that from about 9 million years ago in the left column over to the present time, these different colors representing different sorts of water composition that must have filled the pore spaces under Salar de Uyamata, where we can say must have, because this is a history of first filling the basin with sediments and then having climate become less arid and more arid, and then finally a basin whose subsurface had saline brines in it being drained when the lower river passes through it. And so the pores filling the rocks or holding together the solids of the rocks have really complicated chemical history to them as well, which I would say is very little studied and not yet fully understood. And so your group has the opportunity to do only a finite number of things, I'm sure, and I could suggest hundreds to you. But my major points would be that large parts of the landscape need consideration and not only small details, or have opportunities to offer, that much more knowledge can help in management of the precious natural resources that are blessings in the Atacama Desert, and that in the case, for instance, of the pore water chemistry, that there's still very uncommon, unique opportunities to learn about long-term geological processes in the subsurface.
No, yes.
Thank
Teresa,
you.
thank you very, very much.
To both of you.
I think we have the most important ingredients to start a dialogue now in a plenary session way. We miss the participation of Maria Eugenia Farias and of Zulma Brandoni, but perhaps they can join us during the plenary session. So we can ask for some point of view, but we want to start now the conversation. And of course, if you can raise your hand in the Zoom options, it will be great. So we can move forward. Camila, I think exactly we can take it out and let only without presentation. It's better so we can see the faces. It's better if you agree. Okay.
Okay.
And now I want to start with the reaction that we agree on the chat. Ricardo, if you want to react firstly, and then Gabriel, and then Guillermo. And I will try to connect the things. And Natalie, Cecilia, and Teresa, please feel free to interrupt, to put on, and so we create a dialogue. You don't need to ask me to take the word. Okay? So please, Ricardo.
Okay, thank you, Natalie. Thank you, Teresa. Those were very inspiring presentations and thoughts and ideas about the Atacama Desert. And first, my impression is like about astrobiology, about the talk of Natalie, is that the Atacama Desert is like having the closest scenario to Mars, but here on Earth, and that's impressive. That's really impressive. It's like going to another planet, but staying here. And I have two questions about these topics. Of the Martian similarity with Atacama Desert. One is about biosignatures that you mentioned, Natalie, and you said you spoke about the concept of biosignature preservation. And if we relate this concept to the search for past life on Mars, we are speaking about very ancient times, 1,000 million years ago. The Noachian in Mars is like the transition between Hadean and Archean here on Earth. But in the Atacama Desert, on the other hand, the preservation of signatures is about a different time frame. So how can you relate these two time frames, so to speak? it is possible to expect that we can find biosignatures like remains of organic molecules from that ancient times on Mars, according to the knowledge that you gather here for the biosignature conservation in Atacama Desert? That's my first question, or my first idea.
So, and it's a great question. So in terms of scales, I would say that one thing that Mars has going for it is in terms of environment, the erosion, geology, etc. As you mentioned, it stopped pretty much. It didn't stop. It's different, but it was very effective for about 1 billion years. And then the planet slowed down. So what happened too is that considering the UV radiation, the cosmic radiation, etc., life would not have been able to survive at the surface as the magnetic field was lost, as the atmosphere was lost. So you have to expect that some of life, if it was there, had to migrate in the subsurface to survive. So it's not that we're expecting to find anything, obvious at the surface, and you can see that with Perseverance. So the things that you do have, though, you have different type of biosignatures. You have the physical biosignatures, like stromatolites. And when you're looking at how fast cyanobacteria showed up on Earth, we are at the boundary of something like that on Mars, and it's probably the most complex organism we can expect for a number of reasons, because of the environment, because of the time, and also because Mars never had the same amount of resources or the same amount of energy than the Earth has. So it has to be simple. But morphological remains, those are the kind of things, if we go to the right places, and that's why we are at Jezero, we can find. Molecules are a different matter. Well, they are going to be a lot more difficult to, tear apart from the rest of the environment. But look at what happened with Curiosity. We are finding C12, carbon-12, in abundance in a number of different samples. Obviously, it's not necessarily a biosignature, but we're starting to raise some eyebrows when you also have methane. So it's a mix. And although the scales are not the same, the processes are also very different. And I'm not expecting to find microorganism jumping at the surface right now. I am still of those who are thinking, considering what I saw in Atacama, then life on Mars, if it's still there, and I do believe that it had a chance to start, and if it started, it's still there, then should be closer to the surface than we imagine. So long responses to tell you that it's not equivalent, it's different, but there are still things that are being pointed in the Atacama that are telling us where to look for. And you have biochemical fossils, you have morphological fossils, and a number of other things, isotopes that you can be looking for. It's not going to be obvious unless we're finding stromatolites.
I see, and that evidence about isotopes seems very interesting. I haven't heard about that before. I mean, perhaps it would be possible in the future to have a ratio between the heavy carbon and the light carbon, and from that take some kind of
they did that on a number of samples already, and this is why they were surprised. We have about 30 samples at Curiosity that are showing this discrepancy. But again, it's not an absolute biosignature. Other things can do that, and especially when you have a surface that is being exposed to cosmic rays and etc.
Really interesting. And my second question is about robotic exploration in the Atacama Desert. And considering that the desert is a gigantic place, how do you choose the locality for using and simulate the operation of these rovers can be any place, or the locality should have any feature to be appropriate for this kind of robotic exploration in the Atacama Desert?
So this one is easy. Well, you go to an analog environment because you have a set of questions you want to address and a set of things that you want to do. The Atacama, the Altiplano and the Andes give us a climatic transition that parallel fairly well what happened on Mars. So we can do a wet to dry to wet transition, and you are going up from the Atacama up to the Andes. And then as you go up, you have more UV, you have also the lagunas, the lakes that are evaporating now. You have different interaction between hydrothermal environment. The Atacama as a whole is really very interesting, but we are interested in particular with things that can tell us about what type of life would survive in hydrothermal volcanic environments at different transitions, under the ground, at the surface, being exposed. What is very interesting is to see how some bacteria have kept from a very long time this Swiss Army knife of defenses against UV, against salt, and they are switching them on and off depending on where you find them in the Atacama. So very, very interesting for us. But yes, you do choose your environment or your series of environment as a function of what you want to demonstrate, obviously.
I see. Thank you. Thank you very much, Natalie.
Thank you, Ricardo, for your questions, and Natalie. And I have good news because Sulma Brandoni was able to join us now. And we don't want to lose the opportunity to say hello. Sulma, thank you very much for your time. And we are a little bit late in time, but let me give some words about your background. She's a paleontology from the Universidad de La Plata, and based on the question of Ricardo, she dedicates the study of the Mesozoic and Cenozoic reptiles of South America. She's professor emeritus at the University of La Plata and senior researchers at CONICET. She works in the vertebrate paleontology division of the Museo de La Plata, and she is, of course, a recognized international authority in this field. So, Sulma, I hope you can hear us, and if you can share your thoughts. I want to ask you if you can summarize, and so we return to the plenary and we add your late thoughts in the discussion. Please go ahead. You need to activate your mic, Sulma. I hope you can. Now it works. Please.
Muchas gracias, Rodrigo. No he preparado nada, pero gracias por estar todos ahí. Es un placer verlos y conocer a muchos nuevos de los jóvenes. Gracias por permitirme estar con ustedes. Gracias por estar escuchando.
Un gusto.
Gracias.
Okay. Entiendo, Sulma, entonces que preferirías sumarte a la respuesta y a la conversación más que hacer una intervención ahora, aunque sea sin presentación. ¿Te parece eso lo correcto?
Sí, o sea, estoy con ustedes escuchándolos y aprendiendo, pero no he preparado absolutamente nada. Muchas gracias por la invitación, igual, muy amables.
Great. I switch back to English, and we will come again to the plenary session. And so following the previous plan, and now with Sulma on board, I will ask Gabriel for your reactions, and then Guillermo. Please, Gabriel.
Thank you, Rodrigo. I would like to thank Natalie and Terry and Sulma to be in this seminar. For us, it's a great pleasure. We were thinking that it should be a very good opportunity to have this speaker. and it's amazing that we can has the opportunity to share some ideas about the Atacama Desert, and also to put in a very important scenario this impressive desert. I have some question for Natalie and for Terry. I would like to start with Natalie. It's when I was a student, the first time when you come to Chile, I was in a seminar room, Natalie. I was very excited to hear about the plan to start to explore Mars using the Atacama Desert as an analog. This was, for me, a fascinating idea about how to look the Atacama Desert from a different point of view and to extract some idea to try to search life in Mars on other planets. In the Atacama Desert, one particularity is there is very few water, and the water that there is mostly under the ground. And this is a very interesting scenario to develop soils, and joined with the soils, there is microlife and bacteria living in the soils. And I would like to ask you if there is some soil development in Mars, or something like the evolution of the soil that we look in the Atacama Desert. The Atacama Desert is a saline desert with a lot of gypsum, halite, and other salts. My question is, there is some type of soils development in Mars according to the present understanding?
So if there was, if you are taking the term of soil literally like we define it on Earth, then my job would be done, because then we would have found the bacteria we have been looking for so long. But we cannot define, we use loosely the term soil on Mars because of course we don't have, we haven't found yet bacteria on the red planet. But what happens is that the surface is covered by dust and by debris that's created by what we call the gardening of impact craters. So this is how you crunch the rocks to you know, sand or clay size, or but there is no active formation of soil by bacteria, if this is what you mean. Now there is an interesting the chemistry of that layer and the surface part of the surface of Mars is very similar to the Atacama. We find lots of perchlorates. So this is something that is very of high interest as well, because that explained some of the responses we had with the Viking experiment back in the 70s. We also have lots of gypsum, and this is due to the high volcanic activity 3.5 billion years ago on Mars. So there are many similarities when it comes to mineralogy, interaction of the surface with the lack of atmosphere, but not soil, technically speaking.
Okay, thanks. Now I would like to ask Terry. Terry, I have a philosophical question for you. Because the Atacama Desert preserve amazing landscape, very old landscape, one of the oldest landscape of Earth, and are preserved in the Atacama Desert. At the same condition, there is a large concentration anomalies of geochemical element, a huge anomaly like iodine, copper, and other useful element for the humanity. But at this, for this characteristic, the Atacama Desert is a very important place to generate or to a mining industry, a large scale. And we are at the moment looking that there is a very important perturbation from the mining industry of this beautiful old landscape because the mining industry are trying to extract geochemical geochemical element and to generate an economic industry. What do you think is the role? This is the philosophical question. What do you think is the role of researchers like us that we are trying to create this Landata in order to modulate the extractive industry, and the preservation of this unique place on Earth? I would like to hear about you about the answer to my question.
Gabriel, that's a hard question. So actually, when I had written to Gabriel with that question to him about 2 months ago, I guess. And at that time, I actually went to Google Earth to see, so how wide have the, I think it's the Lagunas project, how big a footprint does it have? And there's another big extraction process up near the Pampa de Tana or Televiche up in that area. And I guess I was happy to see that the Pampa del Tamarugal, like Cordillera de la Costa, are not yet in danger of being completely consumed. There still is time for planning. I guess it strikes me that surely there must be spatial variability in where the surface materials, which Natalie, I do call soils, you know, some places they must be less rich in copper, nitrates, iodine, you know, these important things than in others. And perhaps one of the roles for researchers ought to be to point out the opposite of what the mining companies are pointing out. They're pointing out the richest places where they'd like to extract. Maybe we should be pointing out what are the least mineral or metal or valuable resource rich places and focusing on them as among this set, which doesn't have as much use, are some of these have multiple dimensions of why this is a place to insist be conserved. I've wondered about whether the Chilean geoparques, is that what they're called? You know, whether that is a sort of a something to bring into the Atacama Desert as an example or two, but perhaps if researchers did this sort of assessment of where is it least monetarily valuable to mine, maybe the answer would also be, well, it's not really the geologically, the geoheritage is not really all that rich in these places, but maybe we would discover that there are some obscure, not valuable areas that are geological laboratories with merit to preserve, and that those would be the places to look or to make effort.
Thank you.
Thank you, Gabriel, for your questions. And let me move to Guillermo, and then I think
Natalie?
Natalie,
yes. Want to
Bueno,
react first, Natalie, to the previous question of. Sorry, Guillermo. It's only to.
it's okay, no
is-
problem.
Natalie, want to react to the previous comment, or then you go.
No,
for-
I just a couple of things. First, Terry, I just wanted to mention the lack of definition of soil is for Mars, not for the Atacama. So, but I want to reemphasize your point. Something that's been breaking my heart in the past 20 years is to see how mining has increasingly taken over the desert. And in particular, I think that from my standpoint, we were the last site we are on, Salar de Paranales, for instance. I think that they are starting to look for lithium in the area. So let me tell you what that means for the type of research that we are doing, and then I'll try to get quick at extrapolating what we could do. Salar de Paranales is very interesting and unique when it comes to mineralogy. In terms of mineralogy, it's a very, very large expanse of a one mineralogy called unit. So you have sulfate there. And for a very long time, you have the common evolution of an area. When you're looking for biosignature and trying to extract what is life and what is not life, you have a problem on Earth, is that first, a third of the minerals on Earth are biomediated. So there is that problem to start with. That life has been co-evolving with the environment for 4 billion years. So what is really life and what is really the environment? So you have places like Paranales, where you do have something that is a sort of a controlled experiment. You know that the mineralogy that's there might be biomediated, but it has been evolving on a large scale, spatial scale, all the same for millions of years. So if you can pinpoint something that is different, stands out, you have a way to actually tell what is life in your biosignature and what might be the environment. So these are very precious places, because we not only trying to understand biosignature detection, remember, we're still trying to understand what life is on this planet. We have 123 definitions of it, working definition. We don't know what life is. And we are still trying to pull it apart from the environment. Paranales, as far as I'm concerned, should be fenced for science, period. But that might be an extreme view, but at the same time, it tells you that the Atacama, as Teresa was mentioning, is a unique place on this planet. There are so very few places where you can look in space and time like you do in the Atacama. Plus, you have so many atmospheric things that are happening there. I am going to make a tie that you probably never thought about. Looking at the desert as an analog for planetary missions is already something. On top of that, you have all the climate business that's happening over there, and you have the atmospheric situation where you have the Southern Atlantic anomaly re-entering now into the Atacama. We're still trying to understand whether it has a role on the UV situation or whether it's linked to the Van Allen belt or linked to altitude or whatnot. So there is that. So what happens is that you have those UV storm coming in an environment where you have extremophile. You also have big astronomy observatories in the Atacama, lots of them. The tie here between all of these, the observatory, the extreme environment, climate, these are the exoplanets. This is a place in the Atacama where you can start thinking about what is the climate, what type of life could survive in under certain type of stars. We don't talk too much about that now, but I think you should start thinking about this. And for those reasons, I think that the Atacama should be considered. I understand the industrial and economical value of it, but at least some part of the Atacama that are representative should be dedicated science site. And I'm very serious about that. And I will pull as much weight as I can with actions that are going into that direction to preserve this place on Earth as a sanctuary for science, at least some of them that are representative.
Thank you, Natalie. Very clear message. We need to discuss it, how to move forward on that. But please, Guillermo, now, answer.
Yeah. Okay. Hello, especially to our visitors. Yeah, Natalie, Teresa, and Zulma. I'm very happy to see their faces again. Yeah, It's a long time we haven't seen each other. And I am going to, you have to excuse me, but I am going to put away the word science and a little the Atacama Desert, because I have been working in the Atacama Desert for 50 years, half a century. So I know a little about the desert. So, but I want to make a comment about a very special thing and how the times are changing for good. Yeah, the director of this project is a lady, and our 3 visitors which work can fill a library of several square meters are also women. So I'm very happy about, yeah. And was a privilege to work with Natalie, and I have been working with Sulma since 100 years, yeah. So I'm very happy to see you again. And actually, I want to put in the table only some human details that are not mentioned, of course, are not mentioned in this scientific meeting. And I want to tell you as an anecdotic thing that years ago, Natalie and his husband, a very, very good friend of us, Edmond Green, they climbed the Licancabur. The Licancabur is 6,000 meters. And Edmond Green was, at that time, was 80-something years, yeah? And he is in the Guinness Book, yeah? He's in the Guinness Book because he's a person with more age that climbed Licancabur. But the other thing is that Natalie is a very special person. I think is the only woman that has been diving in the lake in the top of the Licancabur at 6,000 meter altitude. Yeah, and that is quite a record. Yeah, so these people is absolutely outstanding people for me, and I feel that it was a privilege to know them and to work with them. Yeah, and in that way, I trust that we will have to have the chance to see us face to face sometime. Yeah, but it was really a privilege to know you and work with you. And in the same direction, I will not put more words because, as I mentioned before, the work of these women, these 4 women, is outstanding. I am very happy to be in the middle of this meeting. Thank you very much.
Thank you, Guillermo.
Thank you, Guillermo, for your words and context. Very important always.
Thank you, Guillermo.
Yes, and we are arriving to the end of the seminar, but we have one left, Lester Olivares. I want to give you the word, but let me only say after that, I want to come back to Cecilia for the closing remarks of the seminar, and perhaps ask Natalie, Teresa, and Sulma if you want to make a final message to us. But this is, and I ask you for 10 more minutes. It's a little bit more than we prepared and we ask you, but if it works, and so we can finish this. And Jenny is also now, but let us start Lester, then Jenny come back with the hand raised. And okay, Lester, please.
Okay, well, hi, and first of all, thank you for your talks. Has been really informative at the least, and also thank you to the Landata group that they are doing an amazing job. And I have questions that maybe not only Terry and Natalie can answer, but also maybe the Landata group can jump in. So it's about the rare events of rain that happens in the Atacama, and if that is useful for your research, or in fact, like it's exactly the opposite and you're looking for like exactly the opposite end member of the Atacama. Like I was essentially my question comes out of the recent rain events that happen, and well, people that are from the Atacama Desert, I'm from Antofagasta. I know that during the summers you have rain, and that's the way it is. But recently, now I can use like some more fancy algorithm that allows you to say, well, here's where it rained, and you have a lot of like not only water, but also you can see the effects on the landscape. And I could see that there were some in the nearby of Maria Elena. And I don't know, I guess my question is more like, do you have any thoughts about that? Would you use that somehow in your research? Is it important, or maybe it's better to jump into the salt flats in the Andean sectors, or I don't know. I guess that's my question.
Okay, I don't know, Teresa. Well, I'll go first then. A couple of anecdotes on that. We had a rover out, Zoe, during I think that was the 2013 or 2015, one of those years, and it rained. So the Altiplano was blooming. It was beautiful. But while in the Atacama, they got this rain, and guess what happens when you have a bunch of scientists and roboticists with a robot and instruments? They went for the first puddle, and within 24 hours, they could see cyanobacteria in there. So very interesting to see, what happens when you have a one in a X year event. All of this is knowledge. You always learn something. You see how fast you can have organism dormant in the soil that all of a sudden to take advantage of that rain. They don't know when it will happen again. So that give you maybe an idea of what's happening on a planet where you have cycles like that of maybe dormant life. So this is what happened, and something related. I mean, it's just more for the humor here. What happens when you have a 7.8 earthquake and you are with a team on the summit of a volcano? Well, we are coming from California, lots of us, so we're just saying, okay, we'll wait for the aftershock, and we do the science we came to do. So basically, you are scientists in the field. They are going to learn something and do their science.
Great, thank you. Any reaction, Teresa, or we move to Jenny for the question, and then we can.
Lester and I talk 2 or 3 times a week, so we'll talk about it later. I recommend his work to you.
Okay. Good. Thank you, Lester, for your comment. And Jenny, please, if you can,
yes.
Our last question of the seminar today, please.
Thank you so much. Hello. Thank you so much to both speakers, Teresa and Natalie. And I have a question, a combined question to Natalie regarding the biosignatures. I would like to know what are specific biosignatures different than the ones you are usually looking into our own planet? Are you trying to find or thinking to find when you are looking at the samples in Mars? You have mentioned carbon-12 detection, isotopically detection, but this is my first part of the question. And you have mentioned in the last slide you presented, you talk about the ambiguity of detecting these biosignatures, which is something that we also see here on our own planet. How are you tackling this, or do you know what other methods than the standard methods are being implemented?
So thank you very much, Jenny, because this is such an important question. And then this is something we are trying to start to address, in fact, with Cecilia and with Cynthia and others, thinking about our next project. The baseline is that, and this is a personal position that I feel so strongly about, that I am actually organizing a workshop soon, is that right now we are searching for life, looking at its origin, which is tied to environments, because this is what we can do. This is the only thing we can do right now at this point. And we have one data point. And as I said, we don't have a good definition. We have working definitions for life. We don't know what it is. So searching for life elsewhere always come from the standpoint of what we know, of this one data point. For Mars, it's okay, because the environment is fairly similar earlier on to the Earth. And in fact, Mars started before the Earth. 100 million years before, cooled down first, had water on first. So we always joke that we are maybe those Martians that we are looking for, and because of the exchange of material that happened between the two planets. Now, more seriously, I think today, and this usually shocks a little bit everybody when I say that, but the greatest advance in trying to understand what life is didn't come from biology in the past 10 years. It came from biophysics, and it's coming from physics and quantum physics. And what is interesting is that right now you have theories that are looking into or stating that life is the inevitable results of thermodynamics, that the universe at this point in time is tuned towards creating life. Why? Because it's the best way of fighting entropy. And so you have a lot of different models that are starting to show up in theories about that. And I'd like to have those ladies and gentlemen working on those topics sitting together, because there are a number of different theories coming from biophysics. These models are taking some of the work done by Schrödinger 80 years ago, but using a more modern approach. And also information theories. But the point being is that something like that gives you access to what we call agnostic biosignatures. And this has nothing to do with religion, just to say that they are not tied to any biochemistries. If you are looking at thermodynamics and entropy, these are universal processes. And then this would give you access to searching for life as you don't know it. Because right now, we are always starting from our own point of view, or one data point. And that's okay. I mean, the stuff that makes us is very abundant in the universe. And we know now with TESS and all Kepler, etc., all these missions, that planetary environment like Earth are abundant as well. So it may be that it's okay to look for, signatures of life as we know it. But it will be also of greatest importance to try and understand how we can search for life as we don't know it. And the day we are able to do that, I think we are going to be surprised that maybe life is, understand the process of life in the first place. That's an entire seminar and workshop on its own, so I don't want to take too much of your time. But what I'm interested in, just to conclude, is to understand how can we test those biophysical theories? Because if we have a way of testing them, then we are opening a whole new area, excuse me, in biosignature detection. So I'm interested in that too, but that's another story.
Yeah, I would like to complement that, saying that to work with extremophiles is interesting, tackling that last point that you have mentioned, because for several reactions that these microorganisms are doing physiologically, they do not follow thermodynamically. They go through standard reactions that we have seen in normal mesophilic organisms. So when you are talking about thermodynamics, even though we are combining that with biomolecules, they can be giving us some hints on what you are mentioning, how the thermodynamics could modulate a different way of life as we have conceived it all the time.
Exactly, and you can maybe start thinking about the role of environment, not necessarily for the inception of life, maybe some of them are better than others, but also in terms of evolution. Are there other planets where you have more dynamics? You go to complex organisms faster, for instance. But just real quickly, because we're entering a completely different subject, is fascinating here. Something that is being done at the Universidad Católica del Norte with Cecilia and Cynthia that we talked about is also to have those laboratory control of things that we find in nature, for instance, where you know that to the best of your knowledge, you've removed all that is biological to start your experiment. You're growing rocks, you are growing minerals, and then you start seeding those and see how things change as you are increasing the ecosystem on these rocks. So this is an approach for the origins of life and how to, be able to recognize life on Earth. I'm going to shut up because otherwise we're here until,
Thank you so much. Thank you
Oh,
so
great.
much. Oh,
You're welcome.
I think our main conclusion is that we need more time and opportunities to improve this dialogue, and we want to say thank you again. Thank you really for your time, for all this exchange of ideas and experience. And now I want to move to our leader, to Cecilia, to close this seminar, and hopefully to see you very soon again. With this, I finish my part, and thank you for your time and participation. Please, Cecilia.
Yeah, thank you very much, Rodrigo. Zulma, are you there?
Español.
¿Está
Castellano.
Zulma ahí?
Micrófono, Zulma.
Sí.
Sí, sí,
Sí.
Cecilia.
Me gustaría escucharte, aunque fuera en castellano.
Bueno,
Por
tú
favor.
sabes que
Después nosotros
hablo,
le contamos a las colegas.
¿sí?
Sí.
Hablo en español porque mi inglés nunca avanzó demasiado. Bueno, conozco a muchos de ustedes. Me encanta ver a Teresa Jordan, que hace años que no nos vemos, y por supuesto a ti y a Guillermo, que siempre están allí al pie. Los mejores recuerdos para mí, en las distintas partes del mundo donde he estado trabajando, buscando reptiles marinos del Mesozoico, son sin duda los del desierto de Atacama. Y ahora uno de mis nietos es geólogo y está justamente trabajando, aprendiendo en la búsqueda de litio en los salares del lado de Argentina, pero pegaditos a los de ustedes. Para mí lo que estoy contando tiene un significado muy fuerte porque es verme en mis inicios, en los años 70, trabajando con Guillermo, aprendiendo con ustedes y con Guillermo en particular, y ahora veo a través de mi nieto un continuar y ver en los avances en la ciencia, los aportes de la gente joven, los colegas que siguen ahí al frente. Eso para mí es muy, muy emotivo. Se los agradezco muchísimo, muchísimo. Un beso a todos.
Gracias, Zulma. Gracias. Ya, ahora sí. I wanted to ask all of you, Natalie, Teresa, Zulma, and all our colleagues from Landata and from and our invited people and so on. What I mostly understand from your talks and your questions and so on is that to work here in the Atacama Desert and the science in the Atacama Desert is mostly done by leaders. It's what I am so grateful to hear you because we need to try in such a way to say the people that to work in that places that seems that is nothing there. We can find, you can find tremendous and very unique and interesting things, and to waste or use your life doing science in that kind of place. So I think that not only the science, but also the how you understand the value of the Atacama Desert and how you have worked on and you are currently working on is one of the main messages of this meeting. Thank you very much.
Thank you, Cecilia. Thank you all.
Thank you.
Thank you,
Thank you.
Landata, in total.
Thank you.
See you very soon again. And
Nice to meet you.
the final picture for if you can act
Yes, okay.
your cameras and we can take one picture will
Yeah.
be great. And so we finish. And this is really my final part.
We will send you the results of our project for you to understand how all these things will we put together as a result and the report and the roadmap that we are working on. Thank you very much. And the picture.
Yes.
You ready?
Happy
Bye-bye.
Atacama
Okay.
Desert.
Thank you very much.
Bye bye.
Good luck to you.
See you.
Ciao.
Ciao.